Okay, so what I want to do now is I want to look at so this particular element here, which is magnesium. And what I'll do is I'm going to create the Bohr structure for magnesium, and then I'm going to look at the electronic configuration. But what I want to particularly look at in this video are ions, and how do we represent ions using the structure that we've started to learn about. So if we take magnesium for example, so magnesium we can see here its atomic number is 12. So that means that it has 12 protons. So it has 12 protons. And if we remember, protons are positively charged. If it has 12 protons, then it has to have 12 electrons, which are negatively charged. We can see here that its mass is 24. So if we want to find out the number of neutrons, it's going to be 24 minus 12, which is equal to 12. So it has 12 neutrons. So we've 12 protons, which are positively charged, 12 electrons, which are negatively charged, and then we have 12 neutrons, which don't carry any charge. So we can represent this in a structure like this, which is known as the Bohr model or Bohr structure. So protons, we have 12. Neutrons, we have 12. And then what we can do is you can represent each of the electrons. So we have two, so this is the first energy level, so we have 2 electrons here. This is the second energy level, so we have 8 electrons. We're going to have 8 electrons out here. 1, 2, 3, 4, 5, 6, 7, and 8. So that gives us 10. And then what we're going to have then in this outer energy level will be the 2 valence electrons, like so. So that's kind of like what it looks like. And these lines here roughly represent energy levels. Okay, so you have these distinct levels and you have electrons in it. And if you remember, like let's say this first energy level here, or this first orbital, it can contain 2 electrons. The second one can contain up to 8 electrons, and then the third one as well can contain up to 8. And now in this case, we have just 2 electrons in the case of magnesium. Now if we were to represent this using this electronic configuration that we have looked at, what does magnesium look like? So again, it's going to be the same thing in this first energy level here, which represents this first level, just it's the first level away outside of the nucleus. You're going to have two electrons, and we can write it like this. So that's those 2 electrons there, or just represented like this. So this is the first energy level, and you have this sub energy level, which is known as 1s, and the line represents the orbital, and the 2 dashes represent each of the electrons. If we move out here, so in the n is so the second energy level, which would take up these 2 sub energy levels, you're going to have 8 electrons. So 2 of those electrons are in the 2s sub energy level, and then the other 6 are in the 2p sub energy levels. So you're going to have one like so. So this represents, so you have 2, 4, 6, 8. So that's these 8 electrons that you have here, and they're kind of divided into two energy level, into the 2 sub energy levels, but they're all contained within this energy level. And then if we then go out then to this final level here, we have our two electrons in here like so. Okay, within this S energy level, sub energy level, and these are these 2 electrons here. So this is what the Bohr structure looks like. This is what an electronic configuration structure looks like, and then we can actually write this out. So we can say, so magnesium, so it's going to be 1 S2, so that represents this. Then you have 2 S2, which represents this. Then you have 2p6, which represents these 6 electrons here in this sub energy level, and then you have 3s2, and that's this energy level here. So we can see that the outer electrons, or these valence electrons here, which are represented here. They're within an s orbital. So what that means is that this magnesium is an s block element. Now, what we want to think about then is, let's say, so we know that elemental magnesium, for example, is neutral, as in the charge is neutral. You have 12 positive charges in the nucleus, which are positively charged, and then you have 12 negatively charged electrons distributed outside the nucleus, like so. And as a result of that, if you have plus 12 and you minus 12, the overall, if you have 12 positive charges and you have 12 negative charges, the overall charge is going to be neutral. Now, if we take the case of, if we have something like this, so imagine then we have Mg2 plus. Now, so this here is what's known as a magnesium ion. So it's an ion, and it's what's known. So it's a cation. Okay, so it has these two. It has a positive charge. Now, in order for this neutral magnesium to have a positive charge, or plus 2 positive charges, it has to lose 2 of these electrons. So it's going to have to lose this electron and this electron, and it'll have to lose these 2 electrons here, for example. And what will happen then is you will have, in the case of when you lose, so when you lose this electron and this electron, you're going to have plus 12. The 12 positive charges will come from the nucleus, from the 12 protons, minus, so when you lose these 2 electrons, what you're going to have then is, instead of having 12, you're going to have 10 electrons, and then that's going to be equal to plus 2. And that's where the plus 2 charge comes from. So essentially, what would Mg plus 2 look like? It'll look like this, except you're going to lose these. So these outer electrons here, you're going to lose them. So you lose this, and you lose this. So what's going to happen then is that the overall charge then on this whole species here, this whole atom of magnesium, it's going to be 2 plus. So it's going to be positively charged. And the reason it's going to be 2 plus is because you have 12 positive charges in the middle, and you only now have 10 negative charges with the electrons, and it's going to be 2 plus. So it's going to give you a positive ion. So what does that look like in this structure here? Well, what you have to do is you have to actually lose these electrons here. So this is what it will look like. And then if you're to write this structure, write out its electronic configuration, you're just going to write it out exactly the same way here. So you're going to have the first energy level, 1s2, that keeps these 2 electrons, just like the neutral species of this atom. And then you have the 2s2, so again, you have these 2 electrons here, and then you're going to have 2p6, so that's the same as well. And what you notice is that this here is gone, so we lose this. So how do we represent that? What we can do is we can put this whole thing in brackets like so, and we put 2 plus, like so. So what that indicates here is that, so each of these, so this represents this, which represents these 2 electrons here. This represents this, which represents 2 of these 8 electrons. This represents the other 6. Okay, and then you can see that this outer energy level then is empty, and the positive charges from the protons and the negative charges from the electrons are now unbalanced, and you end up with 2 more positive charges. You end up with 2 less negative charges. So as a result of that, you get a 2 plus ion being formed. So this here is neutral, is what the electronic configuration for a neutral atom of magnesium looks like, and this is what the electronic structure for the magnesium ion for this magnesium ion. That's what it looks like if you try it out. And then this is what it looks like using this model, and then this is what it looks like in the Bohr model as well. So that's magnesium. So what we can also do then is we can do the same thing, and we can look at chlorine, for example. So what we can do first of all, so imagine we have chlorine. So you can see it has 17 protons. So it has 17 positive charges. So 17 protons which are positively charged. It's going to have 17 electrons which are negatively charged, and then it's going to be 17 minus 35, which I'm just going to calculate that. So 35 minus 17 is 18, so it's going to have 18 neutrons which don't carry any charge, so 18 neutrons. So what we can do is we can use this Bohr structure and write out the arrangement of these electrons. So you're going to have 2 of them are going to be within here, within the first energy level. You're going to have 8 in the second energy level, 2, 3, 4, 6, 7, 8. Okay, so you're going to have 8 electrons here, and then in the outer electrons, so that gives you 10. So then you have to have 7 electrons out here. So you have 7 electrons here. So this is, so the charges are balanced. We have 17 positive charges, 17 negative charges from the electrons, therefore it's balanced. So what does that look like then if we were to draw this on using this model here? So you're going to have 2 electrons here in this 1s sub-energy level. You're going to have 2 here and 6 here, like so. So we only have 8, let's say we've 8 here, but when we look at this in a bit more closely, you have these so they're not actually all on the exact same. There's the second energy level is broken up into 2 sub-energy levels, and within those, so you have, for example, you have a 2s orbital, and then you have the 2p sub-energy level, which has 3p orbitals, and each one can contain 2 electrons. That's the way it will be arranged. Then out here, then we're going to have, so we have 2 in here, like so. So that's 2. So then you're going to have 5 then. So it'll be something like this: 1, 2, 3, 4, 5. So, and you can see here that there's space for 1 more electron in this p orbital that's part of the 3p sub-energy level. So this is what chlorine looks like when it's neutral, for example. This is the Bohr structure, this is the electronic configuration, and we can then write this out then as well. So it's going to be 1s2. Okay, let's just try that again. So you're going to have, so 1s2, 2s2, 2p3, 3s2, and then we have this one here, which is 3p5. So 3p5. So this represents, this is neutral. So this is the 3 ways that you can look at a neutral atom of chlorine. Now, let's say if we get something like this. So we get a chlorine Cl minus. So this is a chlorine anion. So it's an anion. So this is neutral, this is just chlorine, and this is chlorine just with an extra negative charge. Now, in order for this to have, so this is a minus one negative charge. So how does that happen? Well, in order for a chlorine atom to be a negative ion, the negative charges have to outweigh the positive charges. So what's going to have to happen is you're going to have to add 1 electron to this, and that's going to be equal to, so you're going to have 18 electrons. So what will happen is, if we were to write this in, so we would put an X in here. So this is an extra electron. So as a result, now you have 18. So you have 18. You have 18 negative charges, and then you have plus 17 positive charges. So that's going to be equal to -1, and that's what gives it. That's what will give chlorine this extra charge. So what you will end up with then is something like this. So you have a negatively charged chlorine ion. So this is what it looks like here. So then we put this whole thing inside brackets like so, and then it's a -1 negative, or a negatively charged chlorine ion. So what we can do then is, how does that look then on this system? Well, you're going to have an extra chlorine. So this is the extra electron that you're going to have, and it's going to be within here, within this p orbital. So what will that look like then if we draw out this electronic structure then? So it's going to be, so we do it exactly the same way. So it's 1s2, 2s2, 2p6, 3s2, and then you have 3p6, like so. And so remember, you're going to have 17 positive charges in here, and now you have 18 negative charges coming from the 18 electrons. So this is what it will look like. You can write out the structure like this, and then in order to show that it's a negatively charged chlorine ion, you put brackets around it like that, and you put a minus sign here. So this represents the fact now that you have a chlorine atom that has an extra electron, and as a result of that, the overall charge on the chlorine atom is going to be -1, or it's going to be negatively charged. So that's really how, when we look at the arrangement of, for example, we've looked at chlorine here, and then when you look at magnesium, this is how we can represent ions. So basically it's the electronic configuration of ions and how the electrons are arranged in the individual atoms and what that looks like. So hopefully that makes sense, and it kind of brings a little bit more clarity into, linking all of these kind of concepts into each other. So you kind of build up, you start to look at protons, electrons, and then you start to look at the arrangements of the electrons, and that's kind of like what we started to look at. And we just need models then, or ways at writing these things down so that we can think about them and communicate them with other people as well. So hopefully that makes sense. So that's the electronic configuration of ions.